a triangle ABC with vertices x1, y1, x2, y2 and x3, y3. Then the area of the triangle, as we know, that is equal to 1 by 2 into this 3 by 3 determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. In this video, we are going to investigate the reason why is this third column containing elements 1, 1, 1 is present in this formula, as we see that there is no 1, 1, 1 in the vertices of the triangle. For this, we shall first show that the area of triangle is equal to 1 by 2 into x1 y2 minus x2 y1 minus x1 y3 plus x3 y1 plus x2 y3 minus x3 y2. Then we shall show that this area is equal to 1 by 2 into rectangular determinant x1, x2, x3, y1, y2, y3. Here we shall show that this area is equal to this rectangular determinant 1 by 2 into this rectangular determinant. Then we shall show that this area is equal to 1 by 2 into this square determinant of order 3 cross 3. We first show that the area of the triangle is equal to this expression. For this, we take the triangle ABC to be in the first quadrant. This is x-axis, this is y-axis. Now we draw perpendiculars from the vertices of triangle ABC on x-axis. Here, BD, AE and CF are perpendiculars from vertices of triangle ABC on x-axis. The area of the triangle ABC will be equal to the area of this triangle ABC will be equal to the area of trapezium ABDE. The area of this trapezium ABDE plus the area of trapezium AEFC minus the area of trapezium CBDF. From this formula, we shall obtain the area of triangle ABC. The coordinates of feet of perpendicular are D, x2, 0, E, x1, 0, F, x3, 0. The y coordinates are 0 because the points are on x-axis. The distance DE will be equal to x1 minus x2. The distance EF will be x3 minus x1 and the distance DF will be equal to x3 minus x2. Also note that the height BD is equal to y2, the height AE is equal to y1, the height CF is equal to y3. Now we find the area of these trapeziums. Area of trapezium is equal to 1 by 2 into sum of parallel sides into perpendicular distance between parallel sides. Therefore, the area of trapezium ABDE will be equal to 1 by 2 into BD plus AE, BD plus AE. These are parallel sides, and DE is the perpendicular distance between these two parallel sides. Plus, we write the area of trapezium AEFC will be equal to 1 by 2 into AE plus CF. AE plus CF, these are parallel sides, and EF is the perpendicular distance between these sides. Minus area of trapezium CBDF. BD and CF is the sum of parallel sides BD and CF, and the perpendicular distance between them is DF. Now we put the values of BD, AE, DE, AE, CF, EF, BD plus CF into DF, and we get the area of triangle to be this expression. Now we take 1 by 2 common and multiply uh, all the elements. Now we cancel out the plus and minus sign elements, and we are left with this expression. This is the area of a triangle, which is equal to 1 by 2 into x1 y2 minus x2 y1 minus x1 y3 plus x3 y1 minus x3 y2 plus x2 y3. So we have shown that area of triangle is equal to 1 by 2 into x1 y2 minus x2 y1 minus x1 y3 plus x3 y1 minus x3 y2 plus x2 y3. Now we show that this area is equal to 1 by 2 into this rectangular determinant x1, x2, x3, y1, y2, y3. We expand this 2 cross 3 determinant using Roddick's technique for the evaluation of rectangular determinants. And according to this technique, the determinant will be equal to 1 by 2 into. Here we have formed three 2 cross 2 determinants by associating column 1 with column 2 minus column 1 with column 3 plus column 2 with column 3. Now we can easily evaluate these 2 cross 2 determinants, and we get this expression. After simplifying, we see that this expression and this expression are same. It means the both forms of area are same. So we can say that the area of triangle can be written as 1 by 2 into rectangular determinant x1, x2, x3, y1, y2, y3. So we have proved that area of triangle is equal to 1 by 2 into this 2 cross 3 determinant. Now we show that area of triangle is equal to 1 by 2 into this 3 cross 3 determinant. Now we show that uh, this 2 cross 3 determinant x1, x2, x3, y1, y2, y3 can be converted into this 3 cross 3 determinant. Here is a special rule that converts a rectangular determinant into a square determinant. Take a rectangular matrix of order m cross n with m must be less than n. This condition must be satisfied. Then this m cross n determinant, that is rectangular determinant, can be converted into another determinant with order m plus 1 cross n. Note that here a row has been inserted with each element as 1 at the ith place, because formula is this m cross n determinant is equal to minus 1 raised to power m plus 1 plus I. Here m is the number of rows and I is the number or position at which this row with each element 1 1 1 can be inserted. I can be inserted at any position from 1 to m plus 1. Also note that this method is applicable only if m plus n is an odd number. So these two conditions, that is m is less than n and m plus 1 is odd, must be satisfied. Now we apply this special rule to our 2 cross 3 determinant to convert it into a square determinant. Here number of rows is equal to 2 and number of columns is equal to 3. That is, m is less than n, therefore first condition is satisfied. Also note that m plus n is equal to 5, which is odd. Therefore, a second condition is also satisfied. So we can insert a row containing each element as 1, 1, 1. For the position of row, we know that I is greater or equal to 1 and less or equal to m plus 1. Replace m by 2 and we get I is greater or equal to 1, less or equal to 3. So we can insert our row at place 1, place 2 or place 3. That is, we can insert the row 1, 1, 1 on first position or second position or third position. In this case, we take I is equal to 3. So this 2 cross 3 determinant can be written as minus 1 raised to power m plus 2 plus 1 plus 3 into this 3 cross 3 determinant x1, x2, x3, y1, y2, y3. Note that a row has been inserted at place 3. Also note that the formula was minus 1 raised to power m plus 1 plus I. M has been replaced by 2 and I has been replaced by 3. We can write it in this form after simplifying. Now minus 1 raised to power 6 is 1, and now we take the transpose of this 3 cross 3 determinant and we get x1 y1 1, x2 y2 1, x3 y3 1. Note that here a 2 cross 3 determinant has been converted into a 3 cross 3 determinant, and that's what we were about to prove, and we have proved it. So we have shown that the value of this 2 cross 3 determinant is equal to the value of this 3 cross 3 determinant. Hence, the area of triangle is equal to 1 by 2 into this 3 cross 3 determinant, x1 y1 1, x2 y2 1, x3 y3 1, and this is the formula we often used when the vertices of triangle are given.